alpha v1, alpha 1 v1 plus alpha 2 v2 plus so on alpha k vk, where alpha is are the scalars and I is varies from 1 to k, right? So all the elements, this is the smallest subspace containing S. This thing should be noted that WS is belonging to W subspace containing S. So this is the smallest subspace containing S. So this is the smallest subspace containing S. So V1 is belonging to WS. Similarly, if I take alpha 2 is equal to 1 and all other alphas is equal to 0, so I will get V2 belongs to S or WS, right? So in the same way, all the elements which are in a set S is belonging to WS also. So that's why we are saying that this is a subspace containing S. Rather, this is a smallest subspace containing S. So these things we have discussed in the previous lecture, and we have done some one or two examples based on this. Now I have two questions before moving forward. I have two questions. Uh, One more thing. This 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 collection or this notation, we call it as a linear combination. If S is a set containing k elements, then we can say that this is a linear combination. If S is a set containing k elements, then we can say that this is a nonlinear combination. What is
alpha,
al-
comma, beta, comma, alpha plus beta.
okay? Now these two elements are equal. That means the corresponding element
Yes,
should be equal. So I
yes,
am
sir.
writing here. It means alpha is equal to
0. Beta is
and
equal to 0. Alpha
okay,
plus beta is equal to 1.
yes. So can I write? Do you find something wrong or it's okay now? Can we have find alpha beta such that 001 can be written as this in the form of
Sir,
101 and 0?
alpha की भी वैल्यू 0 और बीटा की भी वैल्यू 0.
Are they satisfying this third equation?
No, sir. 0 plus 0 is equal to 1.
No. That means
Cannot be 1.
then what is your decision or what is your answer now? Can we write this as a linear combination of 101 and 011?
No,
No. Right.
not, sir.
So we are not able to write 011 as a linear combination of 101 and 011. Right? Are you clear, Rekha? Okay.
Yes, sir.
Okay. Rest of
Yes,
the
sir.
students, what are their opinion? They are clear? They are clear. If they are clear, then right. Yes.
If anybody has any doubt, please write.
Okay. So students, you have seen in these two questions that sometimes we can able to write we can able to write an element in the form of linear combination of other elements, and sometimes it's not possible, just like in question number 2. Now I will move toward the question asked by Gaurav sir. So I request Gaurav sir that you please discuss these questions.
Yes, sir. If any student want to reply for these questions, then you can voluntarily come and unmute your mic, or you can write yes on chat box.
Yes, Jyoti is writing yes. Arup Datta is writing yes. Should we call Jyoti?
We can call Jyoti, sir.
Okay,
Yes,
Jyoti,
sir.
question number 3. Yes.
Yes, sir. For question number 3, as S is 1, 0, so for this linear span of S will be uh, x-axis, or we can write it as R, set of real numbers.
Okay. The points on x-axis, because we are talking in R square,
Yes.
so that will be x-axis. Linear span will be x-axis of 1, 0.
Yes, sir. But x-axis will also contain real numbers, so we can write it as R.
Uh, yes, but LS is in R square, no? Then we can write it as x0 set.
Yes, sir. This will be more precise because R can contain y-axis also.
Yes, yes.
So this is basically
X0.
x0.
Yes, sir.
X belongs to.
R.
So this is x-axis, right? Because it's a ordered pair, so we cannot write this as a real line.
So the idea, came to your mind, Jyoti, when you saw this? There is a one
Okay.
element and we are looking for linear span.
Yeah, actually, we did the same thing that we had vector V.
let's discuss. I will make easier for other students who are not able to get any idea. Suppose I have S dash as a singleton set V. Listen carefully, right? If you have any doubt, you are free to discuss with me. And I have another set that is over S. And naturally, S dash is a subset of S, so I am taking one more element. V is there, but beside this, I am taking two element W. So clearly, S dash is a subset of S, right? I want to see that under what condition, what should I apply, what should I use that linear span of S will become a linear span of S dash. I want to see this, right? I want to uh, explore this, right? I want to explore this. Suppose I have S dash as V, it's a singleton set V, and S is V and W. You can see that S dash is a subset of S. I want to check now. I want to check under what condition that linear span of S is equal to linear span of S dash. So first of all, I want that somebody tell me what should be the linear span of S dash. Yes, who will tell me? I will call Avantika. Avantika 18MA060.
Yes, sir.
Avantika, are you getting me?
Yes, sir.
So I am taking S dash as a singleton set V. So what should be its linear span?
Sir, alpha V?
It's a set alpha V, and alpha belongs to some real
R.
number, right?
Yes, sir.
And what is the linear span of S?
Sir, alpha V
Alpha V
plus
plus
beta W.
beta W. And what are alpha beta? They are
Alpha
scalar.
beta belongs to
Generally, I am taking R, but you can take any field also. Now,
yes.
Avantika, can you see the relation between LS dash and LS? Any relation between LS dash and LS? Are you able to see, or are you able to recognize the relation between these two? Khushbu has, I think, already discussed. So you have a hint also. Or you need some time to think.
Yes, sir.
Okay, next I will call Aman Shukla. Aman, Aman Shukla. Okay, Anita Rana. Anita, Anita Rana. Next, Priya. Priya CS287.
Yes, sir.
Yes, Priya, can you able to recognize this anything between LS dash and LS?
Yes, sir, because linear span of S dash is contained in linear span of S.
Yes. How?
So
Linear
because
span of S dash
linear
is a
span of
subset of. Yes, you are saying this.
linear span of
Linear
S.
span of
Yes,
S
sir.
dash is a subset of L of S. How? When one
So
set
because
is a subset
linear
of.
span of S dash is
Okay, carry on, please.
because the linear span of S dash contain करे sir alpha V or alpha V is also contained in linear span of S.
Okay. So you are saying that all the elements scalar multiple of V are also contained
Yes.
in a linear span of S. So when it is
Yes, sir.
possible, but beta W is also there along with. alpha v plus beta v.
Yes, sir.
So when I will say that alpha v is in linear span of S. Yes, Priya.
Yes, sir.
When I can say that alpha v is in linear span of S, because beta w is also there. With
Yes, sir.
alpha
Yes,
v,
sir.
beta w is also there.
Yes, sir.
So when can I say that alpha v belongs to a linear span of S? Yes, Samriti PS 360. You think, Priya? Samriti PS 360.
Yes, sir.
Samriti, Priya is saying that linear span of S dash is a subset of linear span of S because alpha v is contained in linear span of S. Are you getting
Yes,
this?
sir.
So I am saying that why when alpha v belongs to L of S, because with alpha v beta w is also there.
So when beta is 0?
When beta is 0. Okay, correct. If I take beta is equal to 0, then every scalar multiple of v looks that it belongs to L of S, right?
Yes, sir.
So that means linear span of S dash is a subset of linear span of S. Is it okay?
Yes, sir.
Or you can prove like that by the traditional method that one set is a subset of other. I'm going to use in my second part also. That if I take any element in L of S dash, so what should we prove? That arbitrary element should belongs to L of S. Suppose I take one element belongs to L of S dash, right? Let X be any arbitrary element. So X can be written as a linear combination of scalar multiple of V, or we can say a linear combination of V. So I will write it as alpha V, right? But now alpha V can be written as alpha V plus 0 into W. I can write like this. So where it goes? It goes to linear span of S, because these type of elements are embedded in L of S. So I am taking X arbitrary element in L of S dash, and it goes into L of S. So from there I can say that linear span of S dash is a subset of L of S. Now if any student have a doubt up to here, he or she can unmute your mic and you can discuss with me. Sangeet sir, you want to say something?
No, no, no. I'm just looking at the student's response. Oh, my mic is
Okay.
on. Okay.
Okay. No problem, sir. So one result we have got, very good result we have got. Khushbu has also told, and Priya has also discussed, and Samriti has also discussed the result. So what is the result we have got now? That if S dash is a subset of S, then linear span of S dash is a subset of linear span of S. We can generalize this result to any two set which satisfy this condition. Now we want to explore the second thing. And when it is possible, when this thing, which
When
thing
yeah,
made it possible?
if one element of S is the scalar multiple of S dash,
Okay, that
element
means
of S dash.
W is
Yes,
this condition is.
yes, sir.
So thank you, Jyoti. Yes, rest of the students, they got some idea, or I will repeat it again. Yes, students, reply in chat box.
Rohit sir, give them
Yes,
30
sir.
seconds to think. If they have any doubt, then we
Okay.
will discuss. You think, dear
Okay.
student,
So
think
students,
for 30 seconds.
so Akansha Thakur is saying, repeat, sir. Anybody else who have a doubt? Otherwise, I will call somebody else to discuss. If anybody has any doubt, just like Akansha, she's saying that repeat this. Yes, Supriya Sharma.
Yes, sir.
Supriya, is this is clear to you?
Yes, sir.
Okay, so will you repeat this thing for Akansha Thakur
Yes, sir.
and for Avantika? Yes.
ओके सो सर हमने एक एलिमेंट लिया एल एस से एक्स विच इज इक्वल टू अल्फा बी प्लस बीटा डब्ल्यू वो इस फॉर्म का होगा
Okay.
विच इज इक्वल टू अच्छा उसके बाद हमने एल एस डैश से हमने डब्ल्यू लिया विच विल बी इक्वल टू अल्फा 1 वी
Is W belongs to LS dash?
सर आई थिंक सो इट बिलोंग्स टू एल एस डैश
No, because LS dash contain the scalar multiple of V only.
यस सर
LS dash dash contain a scalar multiple of V.
यस सर
So W is not there. But what
Okay.
we are taking? We are
सर
taking
स्केलर
W as a scalar multiple of alpha 1 V.
यस सर
This we are using this. We are we are exploring this thing, right?
यस सर
हम ये चीज लेके चल रहे हैं. W is a
यस
scalar multiple of alpha 1 V. Why? क्यों लेके चल रहे हैं ये?
Rohit sir, I think you should explain. It's better.
Okay,
Yes.
sir. Okay. So students, we want to check again. I am repeating. We want to check whether if I have S as a subset of S dash as a subset of S, I want to check that L of S dash is equal to L of S under what condition? Naturally, this thing is we have proved that if S dash is a subset of S, then L of S dash is a subset of LS. I think up to this every point is clear. Now we have to see the other part. Other part is what? We have to check that whether L of S dash is a subset of L of S dash under some condition or not. So what is the method? I have explained. We take one element in L of S, and if we prove that this element belongs to L of S dash, then we are going to prove X is an arbitrary element. Now, because X belongs to linear span of S, and what is our linear span of S? It is the scalar multiple of alpha V plus beta W. That means there exists some alpha beta belongs to a real number. You can say, you can use any other notation also, alpha 1, beta 1, C1, C2, whatever. But they should be a scalar. So there exists a scalar such that X is equal to alpha V plus beta W. Now I want to see this element in L of S dash. But I know L of S dash contain a scalar multiple of V. It contains a scalar multiple of V. So in order to make this element as a scalar multiple of V, what I have to see? I have to see this part, second part, because first part is the scalar multiple of V, but the second part is not a scalar multiple of V, right? So that's why Jyoti has taken W is equal to alpha 1V. So what we are assuming here that W is some scalar multiple of V for some alpha 1, right? Why we are taking? Because we want that this element should goes to L of S dash. So under what condition it goes to L of S dash? Under this condition, if we take W is equal to alpha 1 of B, because this is creating a problem. So when we take this W as a scalar multiple of V and we substitute, right? Rest are the algebraic things. So this is beta alpha 1B. What should I get? At last I will get gamma into V, as explained in the previously, that after manipulating I will see that I will get a scalar multiple of V. That means this element then belongs to L of S dash. So what is the main highlight or main point here? That we are taking W as a scalar multiple of alpha 1V, and as Jyoti said, that if S dash is a subset of S, and if the second element which is not present in S dash, if that element is a scalar multiple of the elements of S dash, then we say that linear span of S dash is equal to linear span of S. Right? Now, is it okay to all of you? Akansha Thakur saying right. Avantika, rest. Supriya, you are clear now? Why we are taking W is equal to alpha 1V?
Yes, sir.
Okay. So, students, we have seen that I am writing the result again. If S dash is a subset of S, then L of S dash is equal to L of S. When the elements, I am taking here particular example, S dash is over V and S is over VW. So their linear span becomes equal to each other when the element which is not present in S dash is a scalar multiple of elements of S dash, right? So I am generalizing this thing now. Suppose I have S dash is equal to V1, V2, and so on, Vk. I have these elements in S dash, and I have S one element V union S dash. That means these elements are contained in S plus one more element V. So when I will say that linear span of S dash is equal to linear span of S, yes, yes, Supriya Sharma, the same
Yes.
thing, but now generalizing. set in our linear algebra, that when they are linearly dependent or not. So in place of, now we have a collection this V1, V2, so on, Vk. So this is our collection, and I will call this set as S. Suppose if I rename it, if I write V1 as Y1, this is Y2, Y3, Y1, Y2, Y3, and so on, Yk. Now I'm going to define this set S when this set is linearly dependent. Linearly dependent. First of all, uh, I want to, I want that you first of all think on the things which we have done earlier. I am giving you 1 minute to revise. Please see the things. Then I will define the definition. Then I will define linearly dependent for a set. I'm giving you 1 minute. Okay. So I will move ahead. That if I have a set S, uh, set S, I am taking Y1, Y2, so on. These are the elements. So last element will be Yk plus 1, right? I am renaming it. These are k plus 1 elements, so I am renaming it as Y1, Y2, so on, Yk plus 1. I will say that this set is linearly dependent if if one element, if one element from S, I will say that element as Yj, right? If one element from Y, from S, that is Yj, can be written as linear combination, can be written as linear combination of other elements, right? I will say that over set S is linearly dependent if I select, if I able to find one element, at least one element, which can be written as a linear combination of other. Then I will say that over set S is linearly dependent. So we are taking a element Yj here, and we are going to write Yj as a linear combination of other elements. That means there exists a scalars, there exists scalars alpha I belongs to R, such that alpha 1 y1 plus alpha 2 y2. Now yj element is written in the form of rest of the elements. So I will not write yj here. I will not write yj here. So this will become like this. And last one is alpha k plus 1 y. So I will say that over set S is linearly dependent, right? If one element, at least one element, can be written as the form of linear combination of other elements, right? So this is our definition number 2, which is originated from the previous definition number 1. And definition number 1 is originated from the concept of linear span of S dash and linear span of S. Now, if you are clear or you have any doubt, then let me know. If you are clear, then kindly write yes or write no if you are not clear in the chat box. Yeah, here J is 1, because in the previous definition I am writing V as a linear combination of other elements, Jyoti. But here I am not telling that V is a linear combination of other elements. Here I am telling that any element, this set is linearly dependent if I can select one element which can be written as a linear combination of other elements. So that's why I'm taking Yj here. Okay. Okay, see the dependent the dependent word is every we can see in our real life also. Suppose I will tell the student that this definition directly, but not this time. So suppose I have a set S and it contains suppose this element Vk. So this is definition number 3. This set is linearly dependent, right? I will say that this set is linearly dependent if there are scalars. There are scalars alpha I varies from 1 to k, not all 0, not all 0, such that alpha 1 v1 plus alpha 2 v2 plus so on alpha k vk is equal to 0. Or I can write in summation I is equal to 1 to k alpha I vi is equal to. So I say, with the help of this definition, I can say that if S is linearly dependent, a set is linearly dependent if there exist scalars, not all 0, right? That means one of them should be non-zero. Scalar should be non-zero. Either alpha 1, alpha 2, alpha 3, alpha 4. Uh, Out of these scalar, not all 0. Some can be a 0, such that, but their linear combination should comes out to be a 0. Then I say that my set is a linearly dependent set, right? So these definitions are equivalent to each other. I will explain why. Suppose I will talk about definition number 3 and go to definition number 2. But before that, you see the definition number 3 first. For 1 minute or 30 seconds, you see the definition number 3. I'm repeating again. A set S is linearly dependent if there are scalars alpha I, not all 0. That means there exists some scalar which is not 0, but the linear combination of the elements comes out to be a 0. This also quoted the same thing which I have mentioned. That means there is some relationship between these vectors. That's why they are linearly dependent. And we can write that thing in the form of mathematics like this. So see this definition for 1 minute, then I will proceed. At 6:06 I will proceed. And if you have any doubt, you can unmute your mic. Yes, Shivani 929. Shivani 929. Yes, Tanya CS 441. Tanya CS 441.
Yes, sir.
Tanya, are you clear about definition number 3?
Yes, sir.
So will you repeat for me?
Sir, S is a V1, V2, V up to Vk is a linear dependent if the scalar Vi मतलब जो Vi है वो लाई कर रहा है I लाई कर रहा है 1 से लेके K तक और ये नॉन जीरो है. सो हम प्रीवियस रिजल्ट
सारे
से
नॉन जीरो होने चाहिए.
सर यस सर.
सारे नॉन जीरो होने चाहिए. Not
Sir.
all zero. It means
सर मतलब सभी नहीं होने चाहिए वैसे हो सकते हैं कोई यस.
यस, सारे नहीं होने चाहिए. ठीक है, इनमें से कुछ जो है वो नॉन जीरो है या एक भी दो नॉन जीरो है हमारे पास, राइट, बट देयर लीनियर कॉम्बिनेशन शुड बी
जीरो.
So think on this. Yes, Taranpreet Kaur 961. Taranpreet Kaur 961. Yes, Pallavi Puri 916. Taranpreet is with us. Pallavi
Yes.
Puri. Okay, Taranpreet, are you clear?
Yes, sir.
What I want, definition number 3. That means there exists some element in this set S which should be a linear combination of other elements.
Yes, sir.
Can I prove definition number 2 from definition number 3?
Yes, sir.
Sir,
For the time being, let's think. Mute your audio. Shashi Bala.
Yes, sir.
Shashi.
Yes, sir.
Yes.
Shashi,
बेटा answer
are
दो
you
सर.
clear about definition number 3?
सर डेफिनेशन नंबर 3 तो ठीक है पर ऊपर जो सेकंड है ना
So these are the like things.
यस सर.
But both have their importance, right? They are connected to each other,
यस सर.
right? So can you, what is definition number 2? I will repeat it for you. I will say that the set S is linearly dependent if any one of element can be written as a linear combination of other elements, right?
यस सर.
So I am taking as Yj, and Yj we have written as a linear combination of other elements. This is our definition number 2, and definition number 3, which we study in our classes, that S is linearly dependent if there exist scalars, not all zero, such that जो भी है. So can we derive a definition number 2 from definition number 3? Okay, आप definition number 3 बोलो, मैं लिखता हूँ.
सर डेफिनेशन नंबर 3
सर हमारे पास कोई सेट है मतलब n वेक्टर्स का, जैसे b1 b2 सोन bn तक ले सकते हैं।
हमने वी के लिए, हाँ जी।
v के लिए है, is said to be linear dependent if there exist scalars like alpha 1 alpha 2 up to alpha k, मतलब लीनियर डिपेंडेंट तभी होगा अगर इसमें से जो मतलब सम ऑफ स्केलर
हम करेंगे या स्केलर्स को काउंट करेंगे?
तो स्केलर्स को।
Okay, Shashi, you please think. I would like to call Pavan Kumar. Pavan, Ladi Pavan Kumar.
Yes, sir.
Yes, Pavan.
Hello, sir.
Can you give me idea? Yes. Okay.
Yes. हाँ, डेफिनेशन 3 से कैसे डेफिनेशन 2 को जाए वही ना सर?
Yes, sir. Yes.
हाँ, इफ विच हम जिस एलिमेंट चाहते हैं वो लेफ्ट साइड को रख ले और सारे एलिमेंट्स को राइट साइड पे ले ले, एंड उसके बाद अल्फा 1 मतलब अल्फा आई को डिवाइड कर ले तो आ जाएगा सर।
Okay.
उसके बाद कांस्टेंट ले ले अलग अलग।
Okay. Pavan Kumar, your idea is clear, but we have to explore so that each and every student can think on it
Yes, sir.
and can get it clear. Yes.
Yes, sir.
Yes, Muhammad Umar Farooq. Today your mic is working, Muhammad Umar Farooq. Is it working properly or not today again?
Hello.
Yes, who is there?
सर दिस इज अमन शुक्ला।
Yes,
एक्चुअली सर
Aman.
मेरे लैपटॉप में कुछ प्रॉब्लम है सर, माइक नहीं कनेक्ट हो रहा, तो मैंने अपने फोन से भी कनेक्ट कर लिया है।
No problem.
सर जो डेफिनेशन नंबर 3 है उस पे
Okay.
हम 2 पे इस प्रकार से जा सकते हैं सर, क्योंकि डेफिनेशन नंबर 3 में हम ये कह रहे हैं कि नॉट ऑल द वेक्टर्स आर, मतलब नॉट ऑल द स्केलर्स आर जीरो, मतलब कि सर यहाँ पे कुछ ऐसे स्केलर्स हैं जो कि जीरो नहीं हैं। तो अगर जीरो स्केलर्स नहीं हैं तो हमें उन वेक्टर्स को जीरो करना पड़ेगा जो उसके करस्पॉन्डिंग में मल्टीप्लिकेशन पे आ रहे हैं, जिससे कि हमें
Okay.
रिजल्टेंट में
So,
जीरो मिले। और
Okay.
सर जब ऐसा होता है कि जब हम कह रहे हैं कि हमारे वेक्टर्स को हमें जीरो करना पड़ रहा है, मतलब हमें वेक्टर्स को रिस्ट्रिक्ट करना पड़ रहा है, मतलब सर वेक्टर्स तो हैं हमारे पास जिन्हें हमें रिस्ट्रिक्ट करना पड़ रहा है, वो ऑब्वियस सी बात है कि किसी अदर कोई और जो अदर हमारे पास वेक्टर्स हैं उनमें से किसी एक का सर स्केलर मल्टीपल होगा, इसी वजह से वो हमें उसे जीरो करना पड़ रहा है। और सर ऐसे में अगर हम तो सर ऐसे में हम उसे क्या कर सकते हैं कि उस जो वेक्टर है उसको हम बाकी अदर वेक्टर्स के स्केलर मल्टीपल के रूप में लिख सकते हैं सर, मतलब सॉरी लीनियर कॉम्बिनेशन के रूप में लिख सकते हैं।
So what you are saying, that we can't derive definition number 2 from definition
नहीं
number
सर
3?
कर सकते हैं ना सर, मैं वही तो कह रहा हूँ कि जो वेक्टर्स
आप कह रहे हैं कर
जिसके लिए
सकते
हमें,
हैं।
जी सर, जिसके लिए हमें जो भी वेक्टर्स हमें जीरो लेने पड़ रहे हैं सर, जिनको हमें रिस्ट्रिक्ट करना पड़ रहा है बिकॉज वी वांट टू गेट द रिजल्ट जीरो, तो फॉर दैट वी हैव टू रिस्ट्रिक्ट द वेक्टर बिकॉज आवर स्केलर इज फ्री देयर। अगर सारे स्केलर जीरो नहीं है तो हमें वेक्टर्स को रिस्ट्रिक्ट करना पड़ेगा, और सर जिन वेक्टर्स को हम रिस्ट्रिक्ट कर रहे हैं वो ऑब्वियस सी बात है कि वो अदर वेक्टर्स के स्केलर मल्टीपल होंगे सर। यस सर, लीनियर कॉम्बिनेशन में लिखे जा सकते हैं, दैट्स व्हाई वी हैव टू रिस्ट्रिक्ट देम। और इस तरह से सर अगर हम उस प्रॉपर वेक्टर को लें तो हम बाकी अदर वेक्टर्स का कॉम्बिनेशन में उसे लिख सकते हैं। तो सर दैट्स व्हाई वी कैन from there we can derive the definition number 2, I think.
Okay, Aman, your idea is correct, but I will explain it, right, so that each and every student get this thing clear. Okay, thank you, Aman. So see, what is definition number 3? I'm going to explain. If you found any doubt, then discuss with me. So this is linearly dependent. That means there exists a scalar, not all zero. That means there must be some scalar which is non-zero, but the linear combination comes out to be a zero. So let us take alpha j. I am taking alpha j as non-zero scalar because all scalars should not be zero. So I am selecting alpha j which is non-zero. So, but the linear combination comes out to be a 0. That means I don't know about alpha 1, alpha 2, whether they are non-zero or not, but I am taking alpha j as non-zero. So I will have this thing, alpha j and vj plus so on alpha k vk. What we are going to do? We are going to derive a definition number 2 from definition number 3. Because this alpha j is non-zero, so I can write it as I can write it is alpha j vj. I can write it in the form of alpha 1 v1 and alpha 2 v2 and other vectors, right? So alpha j minus 1, vj minus 1 and alpha j plus 1, vj plus 1 and so on alpha k vk, right? Because this is alpha j is non-zero. So what can I do? I can write vj as minus 1 upon alpha j, and rest of the things I write in summation. I is equal to 1 to k alpha I vi, and I is not equal to j. So what I have done, I have written vj as a linear combination of vi. So which is our main purpose. So I can write it as alpha 1 upon alpha j with minus sign v1 and minus alpha 2 upon alpha j, right, v2 and so on, alpha k upon alpha j vk. So we have written vj as a linear combination of other elements, right? So if this proof is okay, think 30 seconds and then let me know whether this proof is okay to you or you want more explanation. Reply me after 30 seconds. First of all, think. So these definitions are equivalent to each other, right? In the classes, we generally, what we do, we talk about linear dependence, that means this definition. We talk about linearly independence, that means this definition. Now, what we are observing here in this lecture, that how they are originating, starting from the linear span and making the relationship between the subset and their linear span, and then making a dependence of one element to the other elements, and then talking about the set. So these definitions are equivalent to each other, right? So that means the vectors are linearly dependent to each other. Uh, I didn't mean that this definition number 3 is not a good definition. In fact, we use this definition everywhere in solving a question or in our real life problem or whatever application. We use this thing. So this is a very good definition, but how it comes, it matters. So this S is linearly dependent if there exists a scalar. That means what I have discussed earlier, that if there is some relationship between the vectors, right? That means there exists some non-zero scalars such that their linear combination come out to be a 0. Then we say that the vectors are linearly dependent to each other, right? So let us see geometrically. I think the geometrically was discussed by, yes. Anyone want to?
Okay.
Sunil sir, you want to say?
In alpha k plus 1 equal to 0. In 2.
Yes, k plus 1 it is. You can rename the vectors and
Alpha
you can take v1, v2, so on, vn. It's basically a finite set, right? So
Sir,
you
actually,
can take
at definition number 2, we are taking k plus 1 vectors. In definition number 3, we have
okay.
k vectors. Yes, sir. So actually, can we
No
take alpha
problem.
k plus
No,
1 equal to 0?
you can take, but here we can also take one more element and then we can discuss their linearly dependence,
Okay.
right? You can take alpha k plus 1 0 and then also you can say, but from 1 of alpha 1 to alpha k, they should be not all 0, right? So I was talking about the example which Gaurav sir has quoted, and uh, I will repeat it again. So geometrically, if we see that over set S, if I take set S containing two elements, so when they are linearly dependent to each other, so sorry, when S is linearly dependent, yes, yes, anybody else? We will see geometrically how it is. Arup, Datta, and Jyoti, they always say yes. Yes, Mukul Sharma. Mukul, I want to discuss with you.
Yes, sir.
Mukul, when they are linearly dependent, when S is linearly dependent,
Seven both are collinear.
when both are collinear. Collinear means
So in same direction.
in same direction. If I take, suppose I take vector space R square and V and W are the two elements. V and W are the two elements in R square. So I say that this S set is linearly dependent. So if we go by definition, then what can you say, Mukul? What can you say about this?
Sir, क्या?
If we go by definition number 3, what can
Sir,
we say about this?
y is equal to alpha time w.
V is equal to alpha time
So
W.
p.
So we can write it as also that alpha W plus minus 1 into V is equal to 0, right? We can write like this. So that means one should be a scalar multiple of other. Then we say that they are linearly dependent. We have discussed in our previous slides also. So geometrically, if we see that V is a scalar multiple of W. Now, if I take W any point on R square, so this is over X axis and this is over Y axis. So if I take W any point, W belongs to R square. So W is on R square. If I take any point, suppose I am taking any point here, and if I put alpha is equal to 0, then I will get another point, uh, 0, 0. So if I draw a line, this is the line joining the 2 points passing through the origin. So what will we get? We get a line. We get a line joining this V and 0, 0. V is a point in R square. So geometrically, we can also see this is our example number 1, we can say. Now, similarly, on a same pattern, if I have 3 vectors, suppose I have a 3 vectors, U, V, W, and now they are in R cube. Suppose I have this 3 vectors and S is a subset of R cube. Then this is your homework to think how can we see when we say that S is linearly dependent. This is I am going to give a question to think that S is linearly dependent, then what can you say about the relationship between U, V, and W? And see it geometrically also.
Yes, sir.
Algebraically. uh, Yes, sir. Gaurav, sir, you want to say?
You have already completed. So see it geometrically, give its geometrical explanation also. What will be the linear dependent set? What will they form?
So, Sangeet, sir, I have some time, or Should I stop here?
Sir, you have 3 minutes.
Okay. So students, this was the definition of linearly dependent. Quickly, can anybody tell me the definition of linearly independent? Yes, Pallavi Puri. When we say the set S is linearly independent, Pallavi Puri. Simple definition.
Sir, you can call Utkarsh.
Yes, sir.
Yes, Utkarsh Rajat. Pallavi, I will
Yes,
call
sir.
you later. Utkarsh,
Oh.
when we say that our set is linearly independent, dependent we have seen. What is independent?
Sir, we can say it is linear independent. In definition 3, we said that all scalars need not to be zero, but in linear independent, all scalars must be zero. Then it is linear independent.
So that means Utkarsh,
All
if
alpha I equals to zero.
okay. So simple definition is that if our set S is not dependent, right? If our set S is not dependent, then we say that it is linearly independent.
scalars are not zero, then what will happen to that part? That expression alpha 1 v1 plus alpha 2 v2 up to so on, alpha k vk. What will happen to that?
Okay, then this will not be equal to 0.
That's what sir is asking.
Yes,
Okay.
that's what I am. Because we are negating the statement, so we go with that step also, right? The, in place of there exist, we will write in negation for every not all 0, such that the expression should also not equal to 0. So we will say like this, that for all alpha I, such that all not all 0, right, we are going to negating the statement. So for all alpha I, not all 0, this expression should also not equal to 0. So that is the definition of our linearly independent. And the other way you are saying that whenever this expression comes out to be 0, that means all scalars should be 0, all alpha I, then this expression will be true only when all alpha I are equal to 0, right, which we study in our classes. So students, I will stop here and let you think on this definition. I will again repeat this definition of linearly independent tomorrow. And this is again a homework. By negating the statement, because linearly independent means not linearly dependent, right? If our set is not linearly dependent, then it will become a linearly independent. So you derive the definition, you find the definition of linearly independent by negating the statement of linearly dependent. So I will stop here and I will discuss this definition of independent tomorrow or day after tomorrow, but whenever we meet. So Sangeet sir, I will stop here.
Okay, sir. Okay. Rohit sir, please give them one question to think. If we have singletons at 0, so is it linearly independent or dependent?
Okay. So students, if we have one set, suppose I have V, then this singleton set is it's naturally belonging to our vector space V. So whether this set is linearly independent or dependent. They have to answer here also, here, sir, or
No, sir. No, they will keep it with them. I asked for you write this question. This is okay. Please write one question more. Singleton set containing 0.
So if V is equal to 0.
Yes.
In question number 1. So what will happen?
So they can think about both of these.
So I will also give one question to you. Suppose I have a set S and 0 is belonging to that set.
Yes.
So is that set is linearly dependent?
Or independent?
Or independent, I think I have not explained very much.
Okay.
So they can think on that part also.
Also think on geometry of this question.
Yes. That's very important. Okay. That's fine.
Yes, sir.
Sangeet sir,
Students,
yes.
Yes, I'm doing it. Students, I'm launching the poll for today. You have 3 minutes to complete it. So before you go to attempt this poll, let me make the announcement, because if you go, some students may not return back due to network connectivity problem. Tomorrow there will be a holiday, so we are not meeting tomorrow. We will meet on Monday at the same time. Link will be posted on the Google Classroom. Okay, so you can join from there as well as in the Telegram group. Second thing is, tomorrow we are going to give you one quiz. It will be posted in the Google Classroom and you can attempt it up to 2 p.m. on Monday. Okay, the quiz will be closed after that. You will not be able to attempt that. It will contain 10 questions that will be MCQ questions. 10 MCQ questions it will contain, and you have to attempt that. Okay, so the questions will be up to today. Whatever Rohit sir has covered, it will contain the content from day 1 that Satya sir started, followed by Sunil sir and Rohit sir. So up to today's session, the 10 MCQs will be there. So I'm launching the poll. So please attempt it. You have 3 minutes to attempt it. Please check if this link is working. Rohit sir, I think they will need some time to answer.
Yes, sir. Yes. Give them time.
Yes, they will
Up
take
to
some time.
6:40. Up to 6:40, we can wait.
Yes, we will wait for next 3 minutes. I think the link is working. That's fine. I think it contains only 2 questions.
Yes, sir. Only 2 questions.
Students who have returned back after attempting the poll, please write in the chat box. You can write done so that we can understand. It should be something different from yes. Asna, what's your problem? Diksha and Upasna, do you have some problem?
Sandeep sir.
Sir, Rohit sir, please share the full link.
Okay, sir.
Sandeep sir, send the link once again.
Yes, sir. I asked
So
Rohit
that
sir
I think
to
Diksha
send.
and
Yes. So for those who are not able to attempt it, we are sending the full link. So don't shorten it. You can send the full link. Yes.
I will send it to you on WhatsApp.
No, you can send it here only. No problem with that. Actually, my WhatsApp is closed. My WhatsApp is closed.
So I will send it to
You can post it. You can post it directly.
you can send in the chat box.
Yes.
Post it on chat box, sir.
Actually, my phone got switch off, so I'm talking from here only, and I have put it on charging, so I cannot access to my
No problem, sir.
WhatsApp. Please let us know the students who are left from attempting the poll. One was Diksha, One was Upasna. I think Upasna has already done it. Diksha was unable to attempt it. Diksha, please see.
So far we have got 37 responses, sir.
Okay. So a student should also attempt it. So whosoever are left, please do it. Taranpreet and Rekha have also joined back, and they are saying they have attempted it. All remaining ones who are not able to access to that, please click on the new link that is shared by Rohit sir. Kiranjit, please click on the new link that is shared by Rohit ji. Please see it. Just try it. You will be able to click it. Whosoever are left, please click on the new link. And those students who have done it, please write in the chat box that you have already attempted the quiz. You can write simply done, sir. You can simply write done. It is done. So just see the number.
Now it's 45.
Okay.
40 response.
Okay. Remaining ones, please give your response.
No problem, Avantika. 41 now. $41, sir, up to now. It's 6:43 now.
Okay, I think we can please note down who have given the response. And
42 now.
if
So,
anybody,
sir,
yes, sir.
Yes. Yes, sir. Yes, please.
If anybody is left and you are unable to go to the link, please let us know.
Sangeet sir, Avara has some problem. Right, that I only one option.
No, that's correct, sir.
So
That's not a problem.
basically, it's maybe she thought that there are so many options. She has only ticked the one option.
Students,
so
what happened?
Next session. Yes, please you continue, sir.
No, sir. You can give some instruction if you're giving to students.
Basically, it's our sixth session, and we already sent a poll with multiple choice, multiple option answers. So you have to think all the options.
Rohit sir, how many have responded?
42, sir. I think now we will not get more responses.
You can refresh it once, and otherwise we will note it down. No problem. We will have the Excel sheet. How many have given response? No problem. Okay. Anything else that we have to share to the students, or otherwise they can leave?
Yes, sir. They can leave now.
Okay. So let us thank Dr. Rohit Gandhi, sir. Thank you so much, sir, for this wonderful lecture. Now, students, the session is closed for today's session. Is closed, so you can leave now. We will meet on Monday. We will resume back at the same time for 40. So be there on time. Thank you so much. Have a safe time. Take care of yourself. It's getting cold day by day, so please be careful about your health also. Thank you so much.